Hi guys, and welcome to a new video. Today we continue our atari breakout tutorial. First we are going to add blocks. Each block's position is defined by the coordinates x and y. It also has a right side which is the block's x location plus the width, as well as a bottom side which is equal to blocks.y plus height. The width of a block is a random value between a minimum and a maximum width value. The height is the same for all blocks. We also gonna need to set a random color for each block. To do so, we have to define an array of colors to choose from. Now we define a class called block that we are gonna use to create many blocks objects. In order to get a random value for width, first we add the value of the minimum width, then we add a random value between 0 and max width minus min width using the function random. We use the function floor to get the integer value because the function random returns a floating point value. To get a random color, we generate a random index that is going to be passed to the array colors. We then set the block's location properties. Now we add the method draw that we are gonna call to draw blocks at the given location, and also set the fill-in color. We are gonna define a function outside of the class block. In this function, we create an array of block objects and set location properties for each block. We stop creating blocks when we reach an x value that is greater than 1070 and a y value that is greater than 300. In each loop, we update x and y as follows. If x is greater than 1070, we move to a new row, which means we set x to 5 and update y. We then call the function draw blocks in the method start of the object game area. Now we need to display the score achieved, as well as how many lives are left for the player. To do so, we define the global value score that we set to 0. Then we create the function update score that displays the score in the defined location. We create a similar function to update lives. But first we have to add a new property to the object ball in order to keep track of how many lives are left. It is the value of bull.lifes that is going to be displayed by the function update lifes. We also gonna get a heart emoji from the website getemoji.com in order to add it to our message. Don't forget to set a different location for the lives counter. And also call both update score and update lives in the method start of game area object. And here's the result. Now let's run the animation again. We notice that the bull wipes the blocks as it moves. To change this, we'll have to redraw each block in every cycle of the animation. As you notice, the blocks are not wiped anymore. But in order to be able to update every component of the game, we will have to clear the whole game area, then redraw everything. So there's no need for bull.clear, because we're gonna clear it all. And also no need for the method clear in the player object. We are also going to change the method move in the object player. Instead of updating the location and redrawing the player, we are going to change the step, which is the new property added to the object. When step is set to 0, this means that the player is not moving. We are going to call move on the object player in order to update its position in each cycle of the animation, then redraw the player. We head now to the function move player. To move the player leftwise, we set the property step to a negative value, and we set it to the positive of the same value to move it right. In order to reset step to 0, we are going to add an event listener for the event key up, which is when no key is held down. The player is moving very smooth now, but we also would like to give it a bigger width. And here's the result. You also notice that the score and the lives counter are not displayed anymore. That's why we are going to call update score and update lives inside the method update of game area. Now we need to implement collision of the ball against the blocks. The ball trajectory should change as you see in this animation. We have to first determine if the ball is touching a block and in which side of the block the ball is hitting. To do so, we are going to create a new function called touch blocks that is going to return a boolean. We know that the ball touches the bottom side of the block if ball.x value is between block.x and block.right, while the difference between ball.y and the block's bottom is less or equal to 15. In case the ball touches the upper side of the block, the condition for ball.x is the same, while it changes for ball.y. The difference between block.y and ball.y should be less or equal to 15. For both the above cases, dy should change to its opposite, while dx stays the same. And of course, the function returns true. Now we know that the ball touches the right side of the block if ball.y value is between block.y and block.bottom. while the difference between bool.x and the block's right is less or equal to 15. In case the bool touches the left side of the block, the condition for bool.y is the same, while it changes for bool.x. The difference between block.x and bool.x should be less or equal to 15. Now for both last cases, dx should change to its opposite, while dy stays the same. And of course, the function returns true. Otherwise, the function returns false. Now back to game area update. Inside the loop 4, we are going to test each block to see if it is being hit by the bool. If so, the block will be deleted from the array of existing blocks. Otherwise, it will be redrawn. Now what if the bool hits the block's corner? Well, this should happen. The bool should go in the same trajectory, but in a different direction. But how do we know that the bool touches the block's corner? The bool touches the bottom right corner of the block if the distance between bool.x and block.right is strictly less than 15. Same goes for bool.y and block.bottom. And by using the same logic, we are going to determine if the bool touches the other corners. You got it. To help set the condition for each corner of the block, we are going to create 4 new functions. Each function tests if the bool is overlapping with either the bottom, the top, the right, or the left side of the block, meaning the distance between the bool center and the block side is strictly less than 15. All the functions return a boolean. Now back to the function touch blocks. We are going to add a new test for the corner collision. We are going to combine the results of the defined 4 functions in order to define if the bool touches any corner, either bottom left, or bottom right, or top left. Whatever corner the bool hits, both dy and dx are changing to their opposites, and the function will return true. Works just fine. Now we want to get a new bool if we lost one. To do so, we are going to add a new method to the object bool that is going to reset all the bool properties, except for lives. we are going to call this function in the method start of the object game area. In the method update of game area, we are going to call bool.init in case bool.y is strictly greater than 580, and we are also going to decrease life's value. Works great. But now, we have to stop the counter at 0 and stop the game. To do so, we are going to add the method stop to the object game area, to which we pass the argument winning. In this method, we are going to design the interface corresponding to either a game over or a game win. First we start by a transparent black layer that covers the whole game area. Then we add a white box to display either a winning or a losing message. The method stop is going to be called in game area.update in case life is equal to 0 with the argument false. And we are gonna call it with the argument true in case all blocks are destroyed. We increase the score by 4 each time the ball touches a block. Okay guys, that's all for this video. See you in the next one. Don't forget to subscribe, like, and share. Like if you care.